Hello and welcome to this section of the MATLAB tutor. What we're going to do here is continue working with symbolic variables and just give you a couple of quick examples to show you when it might come useful that you would need to define a variable symbolically. So let's take a practical example. Let's look at maybe calculating the area of a circle. So typically you might do something like this. If you weren't doing anything symbolic, you would say radius is, let's just say it's equal to 0.75. Maybe that's 3/4 of a meter or something like that. So that's the radius. We have a new variable r pop up over here. And then we might define a variable area is equal to pi r squared, right? So we say pi times r squared, pi r squared. So we hit enter and the area is 1.7671. We have an area variable pop up here. And all that stuff looks great. This is typically how you might use MATLAB. This is an extremely easy calculation, obviously, but you might imagine that you might have an equation or a formula with many variables, maybe you would then have a calculation that you would just basically plug in the numbers and get an answer out. But a lot of times in math, you don't want 1.7671. You'd like a fractional answer involving pi. A lot of times that happens in calculus or trigonometry where you don't really want this. You want, how does it look in terms of pi? Is it 5/17 pi? Is it, pi over 2? What is the answer in terms of pi? So in order to show you that really quickly, let me clear all of the variables that we've been using. So we've been using r and area. We want to get rid of those. So we'll just clear all. When I hit that, all the variables disappeared. Notice when I type in r, it doesn't know what r is, and it doesn't know what area is because I've cleared them. So let me clear the screen. So let's start over and let's define two variables. Let's define sims r, that's going to be the radius, and let's define sims area, like this. Now notice we have our two variables over here, and while I'm thinking about it, let me clear both of these variables. So they've disappeared. When you use the sims command, you can actually put two variables, you can define two variables at one time. So I could do sims r for radius space area. And I can basically define the variable r and the variable area at the same time. And when I hit enter, I have the two variables that are symbolic pop up in the window at the same time. So if you have 4 or 5 variables to define all at once, you can just stick them on the line, just put spaces between them, and then you'll be able to define those there. So we have a symbolic variable r and a symbolic variable that we're calling area. Now I think before what we did was we said r is equal to 0.75 or something like that. So what we're going to do in this case, instead of defining it as a decimal or defining it as if we did something like this, if we did 3/4, notice what's going to happen. If we define it as 3/4, you should remember from the last section, it's going to change r back to a numeric value because MATLAB interprets the 3/4 as basically the decimal 0.75. So let me redefine the radius as a symbol. I'll put it back as a symbol. Now this time we'll do it correctly. We'll say r is equal to the symbol 3/4. So it treats it as an exact value called 3/4. So now it says, okay, r is equal to the value 3/4. All right, now let's do the calculation again. Area is equal to pi r squared. Now in this case, pi is going to be just a decimal, but MATLAB internally represents pi, 3.14 and all the decimals as the symbol pi. R is not a decimal. R is now a symbol that is going to try to keep everything exact. So when I try to compute this area, it's going to tell me that the area is 9 pi over 16. All right, 9 pi over 16. And notice that everything is still a symbol. R is a symbol over here. The variable called area is still a symbol. It did all of that math symbolically, and it gave me a nice simplified fraction involving pi. Now, if I really want to see that as a decimal, I can always type in double area. And it's not going to change anything about the variable area. It's just going to take that number or that symbol that we have defined in terms of area, and it's going to change it back into a decimal. I'm going to see there that the answer is going to be 1.7671, which is what we got before. Notice the variable area and r are both still symbols. When you use the double command, you change it back to a decimal. You're not changing the variable, you're using what's in the variable to give you that decimal. So if we look at what is the area again, we will see that there it is. All right, so while I'm thinking about it, we'll come upon this many times in the tutorial. I want to show you something. Area is defined as the answer that we got here, 9 pi over 16. Now, there is a command called pretty in MATLAB. And if you take the symbol, which isn't defined in terms of a fraction, and you stick it into the function we call pretty, then what will happen is it's going to try to basically prettify it for you. It's going to try to put it in terms of what you might write on your paper. So if you have a very long polynomial or something, it'll try to go ahead and format that for you. So let me clear the screen. And by the way, if I just type in area again, this is what really is stored in the variable area as the symbol. But pretty just basically tries to make it look nicer for you. So now that we have our variables set up and everything else, then I can basically do this again and again. I can say r is equal to, maybe I have a different radius, 19 halves or something like this. Let me put a semicolon to suppress the output. I don't want it echoing that back to the screen. When I hit enter, I've stored the fraction 19 halves into this variable, and I can say the area is equal to, let's do the volume this time. Let's do 4/3 times pi times r cubed. 4/3 pi r cubed, where r is defined to be this fraction here as a symbol. So let me go ahead and hit enter. Well, I called it area, so that's not really true. I should call it volume is equal to 4/3 pi r cubed, like this. And so the volume is equal to this guy. The area is equal to pi r squared, like this. And so I can see that with a radius of 19 halves, the area is going to be equal to 361 times pi over 4. The volume is going to be equal to 6,859 pi over 6. And let me clear the screen. If I really want to make this look nicer, I can say pretty. Let me pretty up the area, and let me pretty up the volume if that's a little bit hard to read. So those are very, very useful things to prettify something. Basically try to change it into something that looks a little bit better. Okay. Now, one final thing I want to show you before we, close this section up. So far I've been using the symbolic variables to hold fractions and to basically do the computations and keep them exact. And a fraction is the best way to illustrate that because it's something that we do in lots of calculations that you might have a real practical need for. But these symbol variables, they go way beyond fractions, right? Let me give you an example. So let's go ahead and define a symbolic variable, and we're going to call it x. So here's the variable x that we've just defined symbolically. This is a placeholder for anything. We can obviously store fractions in there. We can store, later on, we're going to see how to store other expressions in there and functions in there and other things that we're going to get into later. But for right now, let me just show you something here. If you type in what is x, right, and hit enter, MATLAB's going to respond with the symbol x, right? If you type in something like x squared, what do you think is going to happen? MATLAB's going to return that the answer is x squared. MATLAB knows that this is sort of like a generic algebra symbol now. Just like in algebra, we say variables are just symbols for something we don't know. So MATLAB treats it as something it doesn't know. So when we try to square it, it just says, okay, it's squared, right? So this is kind of interesting because we can do stuff like x squared plus x. We hit enter, and it's going to return with x squared plus x. Now, what if we try to do something like x squared plus x, and let's divide that by x, right? Or let's do something even simpler. Let's do x cubed divided by x. So we have x cubed divided by x, and we get an answer of x squared. So MATLAB knows that these are generic symbols. It knows the rules of algebra, so it basically cancels x from the top and the bottom, and it gives us x squared, right? If we go x to the, let's do, to the 6 divided by x to the second power, then MATLAB's going to cancel those guys, what's common in the top and the bottom, because it knows the rules of algebra, and then it's going to return x to the 4th power. So these are, this is sort of an introduction, tipping our toes into the symbolic algebra capabilities of MATLAB. In future sections, I'm going to show you how to use these symbolic variables to do all kinds of algebra things. Expand polynomials, do synthetic long division of polynomials, take derivatives of functions defined symbolically. So you might take the derivative of 5x squared, and then you get back an answer that's a symbolic derivative of what that is. and so on. So again, there's two parts of MATLAB. Half of it is learning how it deals with decimals and how it deals with real numbers and sort of like the decimal point part of MATLAB that most people use it for when they're doing their simulations. And then there's the symbolic part of MATLAB where you get to do some algebra like this, where if I wanted, do long division of 3x squared plus 5, and I want to divide it by x minus 2, you know how to do that long division by hand. MATLAB can do all that stuff too. But in order to get there, I need to first show you how to define these variables, which we've done, show you basically how to manipulate them, and as we go into future sections, I'll show you the commands and the syntax and everything so that you can check your algebra homework and your calculus homework and things like that as well. So that about wraps it up for this section. We've learned how to continue defining things. We've learned how we can do simple calculations with variables that contain symbolic objects, and that's very useful when you're dealing with fractions. Obviously, we've talked about that. We've also tipped our toes into how we can do very basic algebra using these symbols. And just be careful whenever you define them that you don't do something like x is equal to 3/4, because as soon as you do that, x is changed back into a decimal. This is probably one of the most frustrating things students get involved in, because it doesn't look like it should treat it this way. But anytime you type this in, MATLAB treats it as a division. It's going to put 0.75 in there. We've shown you how to get around that. So play around with it, get comfortable with it. Follow me on to the following sections where we'll continue learning more about these capabilities in MATLAB.